For this video, we're going to look at how to think about limits numerically. Again, we're going to do this informally. We'll get to the formal definition soon, but we basically want to use numbers, input and output values of functions to help us answer some questions about limits. This function is one of the examples we're going to look at. So we're going to think about the limit as x approaches 0 of this function. So we're going to look at input and output values. Since we're going to use input and output values, we probably want to make a table of values, although most of these I'll probably actually make two tables of values. We're going to plug in numbers in that table closer and closer and closer to x equals a, or in this example will be closer and closer and closer to x equals 0. But remember, we're not really interested in what happens at x equals 0. We want to be sure that we consider both sides of x equals a, just like when we looked at the graph, we had to look at both sides and make sure those were doing the same thing. So when we look at this example, we'll want to make sure that we plug in numbers on both sides of x equals 0. That's why we'll really have two tables, one for one side and one for the other side. We want to organize our tables so that we can see a trend in the outputs. The textbook examples, if you look in your textbook or in my math lab at some of the examples in the textbook, they don't actually organize the table very neatly. They kind of just expect you to notice what's going on even though the table isn't organized very well. And finally, we want to emphasize that this method really only allows you to estimate a limit. And sometimes you can get a really good estimate, and sometimes your estimate is kind of shaky, but sometimes it's better than nothing. All right, so we're going to look at this example. I've gone ahead and set up a table here, an XY table. So we're going to do one table. We're going to plug in some x values that are less than 0. And then we're going to have another table where we'll plug in some values that have x being greater than 0. So in this first table, I want to pick some x values that are just a little bit left of x equals 0 on a number line. So if I think about numbers that are to the left of x equals 0, that would be negative numbers. And I want to start with a number that's really very, very close to x equals 0. So I might pick a number like negative 0.1. Sometimes I have students that start with numbers like negative 1, but that's not really very close to x equals 0. That's pretty far away. So I would start with a number that's already very, very close to x equals 0 to start with, and then I want to get even closer to x equals 0. So I want to be able to see this trend so that when I get closer and closer and closer to x equals 0, I can see what's happening to the outputs of the function. So I started with negative 1/10, and then negative 1/100th, and then negative 1/1000th. So those numbers that I chose are getting closer and closer and closer to x equals 0, but they are from the left side of x equals 0. All right, on the other table here, I'm going to pick some numbers that are getting closer and closer and closer to x equals 0, but from the right side. So I might pick numbers like positive 0.1, positive 0.01, positive 0.001. So these are getting closer and closer and closer to x equals 0, but from the right side. Notice I don't care about plugging in x equals 0. That's not something I want to even spend time on, is plugging in x equals 0, because that is not what limits are actually about. Okay, here you can see that I've pulled up a screen that looks like a graphing calculator. This is actually running on my computer, but it looks like a TI-84 graphing calculator. And I've typed in the function that we're working with. So I've gone to y equals, and on my y equals, I've typed 2x plus 1 minus cosine of x, that whole quantity over x. And since I'm working with a trig function here, I will want to make sure that I am in radian mode. So I pressed mode and verify, yeah, I'm in radian mode. All right, so I have my function typed into y equals. And then since I have these tables of values, I'm going to actually use the table feature on the graphing calculator to help me do this. But the first thing I want to do before I do that is go to this table set, which is right above window. So I'm going to press second and window to get to this table set. This is at the default settings. So the default is the table starts at x equals 0, and then the delta table tells what it increases x by, and so it'll just plug in numbers one bigger, and so it's going to plug in a bunch of whole numbers. And it'll automatically fill in the independent or x values and the dependent or y values. but I don't really want to plug in x values that are whole numbers. I want to plug in these x values I wrote down over here in my chart. So I'm going to go to table set, that's where I'm at, and then I'm going to arrow down to independent, maybe, there we go, to independent, and then I'm going to go over to ask until ask is highlighted, and then press enter. So what that'll allow me to do is just type in whatever values I want for x. I'm going to leave dependent set to auto, and then that'll automatically fill in the y values for me. All right, so now we're going to go to table. So second graph will take me to table, and now I can just type in the values that I want for x. So negative 0.1 was my first one, then negative 0.01 was the next one I wanted to plug in, negative 0.001 was the next one I wanted to plug in, and so on. All right, so I'm going to look at these y values here for a second, and then I'll plug in the other ones as well. All right, so the table on the graphing calculator, it only makes the columns so wide, so it'll round those output values. But if you want to see more decimal places of accuracy, I've just used my arrows to go over and highlight the first output value. And you can see at the bottom of the screen, there's a lot more digits of accuracy for that first y value. All right, so I'm going to go ahead and write down the values that are here, and I'm going to go ahead and plug in the positive x values and write down those values as well. Okay, so I've gone ahead and filled in the values from my graphing calculator here, the output values for those input values I chose. And what I want to look for is trends in what's happening with the y values. So if I look in this first table, I see that those y values seem to be getting closer and closer and closer to 2. They're all a little bit less than 2, but if I look at the trends and what's going on with those y values, they are getting closer and closer and closer to 2. Now that's not necessarily the answer to my question about the limit. I need to verify, remember, that the other side appears to be doing the same thing. So I can look on the other side with my table over here, and I see that those y values also appear to be getting closer and closer and closer to 2. Now remember, with the table, we're really only ever able to estimate. These appear to be getting closer and closer to 2, but unless I can get more and more accurate with that, then I can't be sure that they don't get close to some other number that just happens to be really close to 2. All right, so for this one, I'm considering the limit as x approaches 1 of x to the power of 2 over 1 minus x. So I want to think about what happens at the outputs of this function when x gets really, really close to 1, but not at x equals 1. It's worth noticing that you can't actually plug in x equals 1. This function's undefined at x equals 1, but remember that that's not really what the limit is asking us about. It's asking us what happens when x gets close to 1. So I'm going to make two tables here. I've got them already set up. I'm going to make one table for x values less than 1 and another table for x values greater than 1. So I want to pick numbers that get closer and closer and closer to 1, but I want to start with some that are on the left side of x equals 1. So I might pick numbers like 0.9 and 0.99 and 0.999. And then for the other one, I might pick numbers like 1.1, 1.01, and 1.001. All right, so then I want to think about what these output values are like. So for this first one, I went ahead and did those on my calculator. I'm just going to write them down here. I got 0.12158 approximately. All right, so I've gone ahead and filled in the table here with the output values, and remember what we want to think about is these output values and what the trend is as x gets closer and closer to 1. So on both of these, you can kind of see as that you look down the table here that those output values are getting closer and closer and closer to some value that maybe, oops, I left a digit off this one. 13547, that may be close to 0.135 something, maybe 0.135 something, maybe closer to 0.1353-ish. Kind of looks like this one side, these values are a little bit smaller than 0.1353, and on the second table they're a little bit bigger than 0.1353. So for this one, this is a good example of why the table method is certainly not the only method you should use. You can get a good ballpark estimate, but you can't really get any more precise than 0.1353-ish. I could certainly do more values on my table and get a better decimal approximation, but you're probably not going to find the actual exact value of this. Once you learn a lot more about limits, you might be able to figure out that the value for this limit is actually natural log of 2. But you're probably not going to recognize that value from looking at some decimal approximations. But certainly using tables can help us get a good ballpark estimate and see if our other answers are reasonable.